Hi guys, welcome back. We are going to be adding and subtracting in scientific notation again today, but with different powers. Okay, so we know when we're adding and subtracting, the exponent numbers have to be exactly the same, and in this case they are not. Okay, so we need to deal with that. So I always look at the bigger one, so 10 to the 7th is bigger. But I know 10 to the 7th is the same as saying 10 times 10 to the 6th, right? If we use those exponent rules we used before. So now I have a 10 to the 6th, I pull it off, right? Because I know I want to get it to a 10 to the 6th. Well, if I do 6.4 times 10, which we did on our last test here, 6.4 times 10 is 64 times 10 to the 6th. Now that's not proper scientific notation, but I'm not going to worry about that till the very end. So now I have the bases looking exactly the same, or not the bases, I'm sorry, are 10, power of 10. So now I can say, okay, well, since I'm adding, I can do 64 plus 5.4, which would be 69.4. And again, I always bring down that 10 to the 6th. And in this case, I am not in proper scientific notation, so I'm going to go ahead and bring my decimal over. So this would be 6.9 to 4 times 10 to the 7th, because I moved the decimal over 1 to the left, so it becomes more positive. Okay, let's try another one of those. Oh, there we go. Okay. So the approximate area of Australia is 9 times 10 to the 6th kilometers squared. The approximate area of Antarctica is 1.37 times 10 to the 7th kilometers squared. What is the difference between the two? So again, I'm just going to rewrite these down here. So we have 9 times 10 to the 6th and 1.37 times 10 to the 10 to the 7th, I apologize. Again, I'm always going to look at my bigger one here. Okay, so I'm going to have 1.37, and I know 10 to the 7th is the same as 10 times 10 to the 6th, because my goal is to get to 10 to the 6th, so it matches this one. So then I'm just going to multiply these two, and you can use a calculator to do that. 1.37 times 10 is 13.7 times 10 to the 6th. And then we still have our 9 times 10 to the 6th. That just came on down for the ride. Now we want to know what's the difference between these two areas. Okay, so I would do 13.7 minus 9.0. Remember, when we have decimals, we line up the decimals. 7 minus 0 is 7. 13 minus 9 is 4, so we have 4.7. And nicely enough, we don't have to change that for scientific notation because it's already in proper scientific notation. Okay, I'm going to give you one problem that I want you to try on your own, okay, since I didn't have an extra problem here. So if I gave you 5.4 times 10 to the 3rd, plus 6.3 times, oops, let's do the times correctly, times 10 to the 5th. So go ahead and try that one and see how you do. So again, I'm looking at my bigger power here, okay, and I want to make it look like a 3. So I actually need to take out 2 10s to get it to be 10 to the 3rd, right, because 5 minus 2 is 10. So I'm going to go ahead and multiply 6.3 times 100, because 10 times 10 is 100. So that would be 630 times 10 to the 3rd plus 5.4 times 10 to the 3rd. So 630 plus 5.4, let's actually line up the decimal properly here. And there'll be a decimal there. 0 plus 4 is 4. 0 plus 5 is 5. Bring down my decimal, and we get 36. So we get 635.4 times 10 to the 3rd. But again, this is not in proper scientific notation, so we're going to go ahead and move that decimal over 2 whole spots. So you're going to have 6.354 times 10 to the 5th. Okay, so we're going to go ahead and try that in our classwork today. Have a wonderful day, and we'll talk to you later. Bye.